Already after time. Can you hear me? Is it working? Okay, cool. Yeah, welcome. How do you like it so far? I think it's one of the last talks of the conference, right? So I hope you still have enough energy for this, because it will be quite intensive. But yeah, let's kick it off. I say, don't lose time. This talk is about microfrontends. Who knows about the term microfrontends? So we heard it? Okay, just two of us. What's the rest doing here? Wants to learn about it, okay. Anybody uses it in production? Anybody has really real-world experience? Okay, one guy. Okay, that's good. That's good. Who knows microservice? I guess everybody, right? Microservices, yeah, okay. Who uses them in production? Okay. Who regrets to use them? Okay. I always do this when I start a talk. I always ask those three questions, even if it's not really related to this. So microfrontends is derived from fully verticalized systems, right? You know, if we as speakers need to apply for a conference, we need to come up with really fancy names, right? With really fancy titles, clickbait, and stuff like this, so that people will attend our talks and that we also get accepted for our talks. Actually, I think a better name would have been microfrontends, just another buzzword, right? But nevertheless, we will find out what microfrontends really are, right? So. First things first, my name is David Leitner. I'm working as a technical expert for a company called Core Technologies. Besides this, I'm a lecturer for post-diploma courses at the University of Applied Science, Technikum Vienna. So I'm not from Germany, even Core is a German company. I'm actually from Vienna. So what do I do as technical consultant? Actually, I mainly focus these days on front-end related stuff. So I travel from customer to customer and try to fix the front-end somehow. I have a huge background with backend development, actually, so I somehow moved into this front-end area, and I stayed there, and I like it, actually. I never thought that I would say it one day that I like JavaScript, but it is like it is, and it is cool. And besides this, I do a couple of things around the community. I think we all should do this, right? So, but this is not really the important stuff about me. You don't need to remember this. What you should remember is that I'm writing code nearly on a daily basis. I think this is very important, because I have the feeling that people, I think it's important for two reasons. The first one is that I have the feeling that people start to feel ashamed of writing code sometimes, right? Everybody wants to be an agile coach, everybody wants to be product owner, everybody wants to manage something. But you know, delivering source code is still one of the most beautiful artifacts we can deliver in our industry, and we should never feel ashamed about this. That's the first one. And the second one, why I think it's very important that I'm writing code, is that all what I will tell you today is not what I read on Twitter, it's not what I heard on conferences from Facebook or co. It's what we made as experience, right, in customer projects, right? It's not the selling talk, it's really the hard truth with all the disadvantages, right? So a definition of microfrontends, it's actually this here. Okay. Shit. Sorry. Yeah, you know, I use Windows just for presentations, and every time I use it, then it has some issues. Last time I used it a month ago with the same deck, actually. That's the only deck I have still on PowerPoint. The rest is already on Google presentations. And I need to start a Windows virtual machine every time for this kind of microphone presentation, because I started this topic already a couple of years ago, and it was still the same route, and you know, I extended it, but the PowerPoint deck is still the same. And last month, my Windows told me that I need to update it during a presentation because it was really old, and now I need to activate it. So Windows doesn't seem to be my best friend, actually, but nevertheless. So a definition about microfrontends. Well, there's an issue with this. I would have liked to start this presentation with some kind of Wikipedia definition or something like this, but there's no real common understanding about this term, right? So maybe some of you already use it. Well, I think they have total different understandings maybe than me, what microfrontends are and what we are talking about. So, but nevertheless, there's one from Michael Gears I like, because what he says is that the idea of microfrontends is to extend the concept of microservices to the front-end world. And this one is quite good, and actually it's genius, because what it says is we just, we just take the benefits of microservices and move them to the front-end world, right? And hopefully this works out. Well, it's not that easy, but at least we have a baseline, right? We need to understand microfrontend, so I will give just a quick look at microservices again. So just as a short recap, because if I want to understand a new technology, I always ask myself 3 questions, right? Who did it? Why did he do it? And in which context did he do, right? And at least for microservices, that's quite clear, right? There's this great book from Sam Newman, Building Microservices, and he defines microservices very well. He says, microservices are small and focused on one thing, and we do them because we want to be autonomous, right? And that's it. So actually, even the definition of microservices is quite micro, right? So why do we do them, right? Because lots of CV-driven and excitement-driven development, but also because we want to be autonomous, right? So why do we want to be autonomous in the first instance? Well, there are a couple of reasons why autonomous services are important to us. The first of all is we can independently deploy, right? We can deploy each service on its own. We are autonomous in operations. Our services start on their own, our services die on their own, our service has their own persistence, and our services can scale on their own, right? And we are technology agnostic. I mean, we can be. We don't have to be. I think that's important. But actually, it's a good thing that we can build services with specific tooling, right? With tooling that fits our problem best, with the programming language, with the framework, which is the best one for the problem we are facing, right? We are based on standards. I think this is totally underestimated. Actually, that's one of the best things microservices brought us in comparison to service-oriented architecture, right? Everybody is using real open standards these days to communicate between services, right? There are no proprietary protocols anymore. People use HTTP to talk between those services, right? And this enabled actually a lot. We support parallel development, right? Software eats the world. We are building tons of software each day, and we need to parallelize this stuff, right? That's where microservices usually also have. And we have a small interface surface, right? So the thing we expose to the outside of the world is quite tiny, right? We just say, okay, those are the 5 endpoints you can use, and we have a strong encapsulation by this, right? Mainly because, you know, microservices run in their own processes, and this, of course, supports this, right? So this is why we want to be autonomous, right? So where did it came from, right? The third question. Well, Sam Newman stated them clearly as a contrast system to monoliths, right? That's what he said. That's why he decided to give it the name microservices. That's why he wrote this book, because it says it's a contrast system to what we have so far, right? So because what did we have, right? This is how it looked like, right? When I started programming. It was the application, it was the database, right? If you wanted to change something in the business logic, you went to the application. If you wanted to change something in the persistence, you went to the database, right? This was easy as this, right? It was not bad. I wouldn't say it was bad, but it was easy as this, right? And then there was this book from Brian Foote and Joseph Joda, Ball of Mud. Who knows Ball of Mud? Paper. Nobody. Really? Okay, that's interesting. One person. And this paper is actually a really interesting one. So if you don't know it, you should read it. But the issue with this paper is that it was totally misunderstood, in my opinion, because actually a ball of mud was nothing bad in their definition. A ball of mud was just a very cohesive software module, right? But nevertheless, people saw balls of mud everywhere. They started to see them everywhere, and they said, hey, what you're building here is a ball of mud. And then they said, oh no, what have I done wrong? How could this happen? How can I solve this issue, right? And then they told you, yeah, you need to slice. You need to slice your application, right? And that's what we did. We sliced our application. And we said, okay, we now have a front-end layer, we have a business layer, we have a persistence layer, right? And we have those 3 layers, so we sliced it, right? And as said, software eats the world, our layers became bigger and bigger. We got all these ripple problems, right? So if you want to change one thing here, you need to go there, 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 right? This is called ripple effect, right? This really sucked. And on the other hand, the same people which were in your office 2 years earlier, right, which told you that you're building a ball of mud, are coming in again and telling you, yo, congratulations, you now have 3 balls of mud, right? And then you say, oh my God, how could this happen, right? What have I done wrong again, right? And then they say, yeah, it was about slicing. And then you say, yeah, but we sliced, right? And then they say, yeah, but you sliced in the wrong direction, right? And it is quite correct, right? Because we shouldn't slice based on technical attributes. We should slice based on domain attributes, right? And this is what we did, right? This is where those vertical systems came into play, where we say, okay, we have a user service, we have a product service, we have a payment service, we have a shipping service, right? So we really slice vertically, right? And this is actually what Sam Newman took, right? He refined it a little bit. He said, okay, each service should have its own persistence, right? We slice it a little bit smaller. And this is where microservices were born, right? Just to give you a short recap. And with these microservices, we have all these advantages, right? We have independent deployments. We are autonomous in our operations. We are technology agnostic. We can be. We are based on standards. We support parallel development, and we have small interface surface, right? this was a great time, actually, and I remember quite good. I was at the conference 2014, GraphConf conference in Bratislava. And it was really cool because I was there in the morning and there was a talk from Amazon. And I remember like it was yesterday. This guy from Amazon came to the stage and he said, you know what? We currently, at this moment, right? And it was really, it was a fascinating moment for him. He said, currently at this moment, we have 1,000 microservices running in production, right? And everybody was really shocked and said, oh, holy shit, right? How do they do this? How can they run thousands of microservices in production, right? And then there was a lunch break. And after lunch break, there came a guy from Netflix. And he obviously also heard the talk from Amazon. And he said, Amazon, that's sweet. That's really sweet. We have more than 3,000 microservices running in production, right? And everybody was more shocked, right? And then they showed you all this picture and everybody said, oh my God, right? How do they do this, right? That's amazing, right? And then you came back to office on Monday and took a look at your Git repository and you saw, okay, 3 microservices, right? Sprint goal, more microservices. So this is how we developed. But actually, a couple of months later, there was a talk I attended from Stefan Tilkov. Does anybody know Stefan Tilkov? He's one of the founders of InnoQ, yeah. That was clear. And he said a very, very wise sentence. He said, but wait, our microservices have actual human users, right? And this sentence actually flashed me a lot, right? Because these crazy pictures came to my mind again, and I thought, well, actually, that's true, right? I mean, all those Amazon, Netflix, right? How do they actually make this, right? How do they encapsulate, right, or hide all this complexity they introduced by microservices behind a solid and even consistent UI layer, right? How do they actually really do this, right? And you don't find much talks about these topics here. You don't find much blog entries how Netflix does this, right? Because if I go to Netflix, I don't care if they're running 3,000 microservices. I just want to watch my movie, right? That's for me important, right? And that's really hard actually to find this out. And I did my own observations, right? And I went to our projects and I wanted to find out what we actually do, right? I mean, we don't have thousands of microservices, but at least we have a couple of them. And actually the pattern I found out was always the same, right? We had this microservice architecture and then on top we had a front end, right? And then I thought about it and I thought, I mean, if I go to my colleague now, right? And if I tell him, you know, we have microservices, but you know, we have one persistence layer, right? Then he will tell you, that's wrong, David, that's totally wrong, you cannot do this, right? He will tell you, that's wrong because you need to slice down to the persistence, right? That's how it worked, and that's what is correct actually, right? Otherwise you cannot really scale. But somehow for the front end, this is not really valid, right? Because they say, you know, I don't know, maybe we can have a front-end monolith, right? It's just an implementation detail, right? And I think this is one of the main issues, right? And this issue is mainly driven by people like me or even by people like you, right? Who have a very strong back-end area focus, right? Most of the people who are thinking about architecture in projects are mainly focused on back-end systems, right? They don't have so much clue about what's going on in the front-end world, actually. And that's the issue, right? For us, that the front end always was, you know, this implementation detail, right? It was a little bit of HTML, jQuery hacking and stuff like this, right? But over years, this totally evolved. And still, the problem was that for us, you know, our architecture, our slicing always ended at those beautiful crafted REST endpoints, right? But that's actually not what users do, right? They don't use a postman to access your service, right? They go over the front end. So I think this is one of the big misunderstandings, right? That the front end is not an implementation detail. It's actually a mission critical part of your microservice architecture, right? And I think this is one of the key takeaways. At least for me, this was a couple of years ago. And because why is it like this, right? Because if you think about it, if you think about this backend platform here, right, and then we have the front-end platform, yeah, and in the backend platform we have all these beautiful advantages, okay? I've already told you, right? But if you go then to the front-end guys and say, hey, can you show me a little bit of the front-end code? I'm interested in this stuff, right? This is what you actually will see, right? And then you say, oh my God, looks interesting. How could I have overseen this, right? And then you go again through this list on the right-hand side, and then you say, can we actually independently deploy this stuff? And they say, no, that's not possible. Can we run this stuff autonomously? No. No, it cannot run autonomously, right? It's perfectly glued together. It took us a long time to do this. Can we be technology agnostic? Well, no. And actually, I was at the NG conference in Paris 2013, I think. And this was really cool because I was there. And there was a keynote from Google, right, for Angular. And everybody was expecting some cool features for AngularJS, right? And then those guys from Google came to the stage and said, you know what? AngularJS, this is not really maintainable anymore, right? It's based on old standards. We will totally replace it with something new. And we'll even call it the same, or nearly the same, that we mess up Google totally. And there we found out more. Maybe being a little bit of technology agnostic in the front-end world would not be that bad, right? So, but in this case, we are not, right? We don't have the standards here, right? We cannot say, okay, we can interchange here between front-end frameworks. We decide we go with Angular, or we decide we go with React, or we decide we go with Vue.js, but it doesn't matter. We cannot interchange this really, right? And we are not really based on standards. I mean, this is getting better now. We will talk about web components and other stuff a little bit later. But actually, web components is still a draft, right? It's not a finalist standard. And also, beside this, we don't really have the support of the frameworks for the standards yet, right? And we don't really support parallel development, right? And this is usually where it really starts to hurt, right? Because if you work for big enterprise applications, you cannot work with more than 5 people on a front end, right? But you need to scale it somehow, right? You need to deliver more features, right? But somehow you cannot parallelize this then anymore, right? If you have such a front end monolith. And we don't have real small interface surfaces, right? So we lost it all, right? We lost it all on the front-end layer. And this is what people say a front-end monolith was born, right? So they call this front-end monoliths. And what we usually do with monoliths, we already know this, right? We kill it with something which is prefixed with micro, right? And so people come to me and say, hey, David, we need a micro front-end to solve our issues, right? And this is the funny part. And then I always say, yeah, that's cool. we should talk about this. But the issue is, as I mentioned earlier, right? There is not a micro front-end, right? This term is totally shitty, right? It's not defined. We have no common understanding about this term, right? I like this, right? There's this joke about JavaScript development. I always bring it actually. Sometimes if I write my JavaScript code, I always say fuck this, right? Because the language is sometimes really bad. But you know, if you say fuck this, you actually don't know what this currently references, right? So that's one of the issues, right? So micro frontends are not really defined yet. That's the point, right? So let's dig into this now, right? This is actually where I wanted to come to. I just wanted to give you a short introduction about this whole topic and why it's important. So what I did now is I grouped different ways of micro frontends I've seen so far in projects, and I tried to group them together to make them understandable. And I want to show you those approaches and what are the advantages and disadvantages of them, right? So the first one is the hyperlink integration. It's maybe the most obvious, and it's also the most simple one, right? So the hyperlink integration micro frontend approach is pretty simple, and you just say, you know, we slice really from the front end to the back end, right? We slice end to end, right? And we say, okay, we have a catalog front end, we have an ordering front end, we have a payment front end, and we have a shipping front end, right? And this sounds really good. I mean, from an architectural perspective, this looks nicely decoupled, right? This is usually how you see your architecture on PowerPoint presentations, so it looks okay, right? And all this is glued together by hyperlinks, right? But then you will see first issues here very soon, right? The first one is that the front end usually loves to break your service boundaries, right? If you think of a dashboard, you cannot fully verticalize this, right? Because on the dashboard, you normally want to see some kind of products. You want to see your latest orders, maybe. You want to see your payment and shipping details, right? So what do you do here? You cannot say, okay, I fully verticalize this because I need all those services, all those bounded contexts in one front end, right? And this is actually where Sam Newman brought this backend for frontend patterning, because actually what you get if you do it like this is that you have a lot of overfetching and over requesting, right? You need to make a lot of requests in the frontend to really aggregate the stuff together, and usually that's very intensive for the client, right? Especially if it comes to mobile development. That's why he introduced this backend for frontend pattern, where he said, okay, each UI service actually have a very consumer-driven API in the backend, right? Which gives him the data how he needs it, right? And they do the aggregation. So the advantage here is that this stuff here is still very generic, right? Those services are very generic. The purpose is reusability here, right? And those services are very consumer-driven, right? They give you the APIs how you need them in the front end, right? So that you really just get, I don't know, the first 10 products, right? And don't get 100 products and need to filter them on the client, right? That's the idea behind this backend for front end. And this actually worked really good for us. A couple of times we already used this. And if you think about it, you can also use something else as a backend for front end. You can go for something like GraphQL, for example, right? Which somehow fulfills the same idea in this area, right? And if you think about this now, we solved our breaking service boundaries problem with backend for frontend, with backends for frontends. And if you think about this now, you have a lot of the advantages you actually have from microservices, right? You have independent deployments. You can deploy all this stuff on your own. All those services run on their own. All the frontends run on their own. You can really build this stuff technology agnostic, right? You can use React here. You can use Angular here. Sorry, you can use Vue.js here, and you can use the framework of the month here, right? Doesn't really matter. You can do it whatever you want, right? And you support parallel development, right? So it looks quite promising. But then you come out of this meeting where you decide, hey, Hyperlink integration is great, let's go for this, right? And you come back on the next day and people start to cry, right? And you say, hey, why are you crying, right? We solved all the issues we had, right? And then he says, you know, and I'm the UX designer, and I really hate your decisions, right? Because actually what customers expect is that one company has one website, right? And that's true for a reason, right? And we have this kind of problem in the front-end world, right? And if people from microservices say, just take the advantages of microservices and bring them to the front-end, this is not really valid, right? Because of course, also in the microservice architecture, we have some kind of reusability, right? We have some kind of common jar, we have some logging and stuff like this in it, right? But it's really tiny in comparison to the front-end world, right? Because the front-end still contains, most of the stuff it contains is UI rendering, right? And usually you want some kind of similar UI on your services, right? You want some kind of corporate identity, right? You don't want to end up like Windows, where you see on every screen that this was designed by a different team, right? And you know, okay, this was designed by team A and this was designed by team B, right? And they don't talk to each other, right? So actually you want some kind of consistency on your front-end layer, right? And this is this kind of a usage problem we have, right? I summarized it here with a simple example that you say you need some kind of navigation, right? And you say, okay, let's implement some navigation, right? And you go to the catalog team and say, please implement the navigation. They do it, right? And the ordering team also does it. They already do it a little bit of different, right? The payment team, has anybody ever worked in a payment service? It's really stressful. I hate it. I never want to work with payments anymore because I'm always afraid that I do something wrong and the transaction go into the wrong direction, and it's really always stressy. And so they are really stressed out and they fully forget it, and shipping is anyway somehow weird to do it on the left-hand side, right? So your application looks totally shitty at the end, right? So how can we solve this? Actually, it's hard to solve in this kind of architecture, right? And this is where we end up, right? This is what designers expect, this is what consumers expect. Designers actually always expect a little bit more than consumers, right, to be honest, right? And this is what we deliver, right? So this is somehow the issue summarized, right? So if we take a look at this again, right, we have independent deployments, we are autonomous in operations, we are technology agnostic, we are support parallel development, but we don't have a consistent UI and UX usually, right? And we don't have smooth user interaction because you always need this round trip to the server if we change the site. And we also don't have fast loading, right? Because I mean, it's fine that you can use the framework of the month here, right? But the client needs to download a new framework for every page, right? And this can be really a problem, especially when it comes to mobile applications, right? So this is not the best solution, right? So let's take a look at a different flavor. The second one is build time integration, right? So that's the idea is actually the same, right? So you also slice from end to end,
But what you do is you don't do the integration via hyperlinks, you do the integration during build time, right? So you have some kind of UR shared stuff here, right? Which, for example, defines your single page application framework, your components. And during build time, you bundle all this together to a monolithical bundle, right? And this is usually done by monorepos, so-called monorepos. So you put all this stuff in one repo, right? So you have one package JSON, for example, which defines your dependencies. You have all your shared resources there. So this allows you to simplify the dependency management, right? Because you say, okay, you have one Angular version, right? And all your applications should use the same Angular version. And if you want to upgrade the Angular version, all applications need to upgrade the Angular version, right? So this idea was mainly driven by Google. They did this a couple of years like this. And also it allows you to do extensive code reusage, right? Because you say you have a button, right? And you put the button somewhere in the repo, right? And you don't need to push it to Nexus, and somebody needs to grab it from Nexus. And when you change something on the button, you need to push it again, and somebody needs to pull it again, and somebody needs to update the version. You just have it in your shared repository, right? So it turns out that it really simplifies the way of sharing stuff with each other, with all its dependencies, with all its disadvantages, of course. But in the end, it's a good way to allow or to reduce the boundary that people share the stuff between the services, right? So if we take a look at this one, it's totally different to the Hyperlink integration because it doesn't support us in doing independent deployments anymore because we at the end have one monolithic bundle, right? It doesn't really support autonomous operations because we have one Angular version running, right? And if Angular breaks or something goes wrong, it bubbles up and breaks maybe the whole application, right? We are not technology agnostic anymore because we defined one framework in the package JSON, but we still support parallel development, right? If you slice our application clever enough, we can support parallel development, and if you say, okay, we have some clear boundaries between the teams, this works quite well. And the big advantage is that we can easily or more easily have a consistent UI and UX. We support smooth user interaction. And I mean, fast loading is always a thing. There are always ways to achieve fast loading. If you think of lazy loading, but out of the box, you would actually not have it. But there are simple ways to achieve it, right? So it's actually, if you take a look at the list, it's the total opposite to what we've seen before, right? But it's still not really good, right? Because it's really more or less a monolithical approach, right? We just slice the monolith better, right? So what else can we do? There's something which is called transclusion. Who knows what transclusion means? James, go out. You know it all. No, just kidding. Yeah, transclusion is a fancy word for, I would say, runtime integration, right? I use transclusion because people don't know it and they say, oh, transclusion, cool, I learned something. But actually, you could have called it runtime integration. So it works in a way that you integrate your stuff on the server, right? So actually, it looks really similar, but the bundling is not done during build time. The bundling is done on the web server. And this is normally done by server-side includes or edge-side includes, right? So you have this, for example, Nginx supports edge-side includes, so you can just, have those includes and you say you aggregate your page during the server runtime, right? And this works good. And one of the main projects here is, for example, oh sorry, I don't have the logo here, is Zalando. Zalando does this a lot, so they do a lot of transclusion during the server-side include, right? And if we take a look at this now, we have independent deployments because we can deploy our frontends on their own, right? Because they're included during on the server side, right? We have autonomous operations. I mean, this is actually that's a tricky one, but actually we could have it because we could say we do the transclusion in a way that we have some kind of fallbacks if services are not available. We are technology agnostic. We are not technology agnostic, sorry, because we still have the thing that we say, okay, we have one framework defined. We support parallel development. We have a consistent UI and UX. We have smooth user interaction, and we don't have fast loading if we don't do some tricks here, right? So we somehow improved it, but we still have a couple of issues, right? Oh, here it is. This is actually what Taylor does. Taylor is a framework from Zalando which supports you in doing this. If you want to go in this direction. We used it a couple of times. It's really a cool thing actually, but it comes with some kind of overhead. You really need to learn this stuff to really get the benefits out of it, right? Fourth approach, actual integration. This is what we see a lot currently. This is actually what we also try to do a lot because actually it's some kind of a good hybrid approach. So what is app-shell integration? App-shell integration is the way that we say, okay, we have some kind of shell which loads our micro frontends, right? So we have a shell where we say, okay, if we go to the product overview, we get the product micro frontend. If we go to the checkout overview, we get the payment micro frontend. And the aggregation is again done on the client, right? And the stuff is lazy loaded when you click on this stuff, right? And the cool thing about this app-shell integration is actually that you have some kind of UX improvement only by the fact that you say, okay, you have at least a common header, right? Because the microphone doesn't bring the header is part of the app shell, right? And you have a common footer, right? So it's from this perspective already very good, because if you think of a user, what's the first thing you see, right? If you go to Amazon, you see the header, right? And you see the logo and you see the menu. But for example, if you use Amazon a lot, you will find out actually that they have quite many inconsistencies between the micro frontends, right? Because they do some kind of this app shell integration a lot here. And it's not that bad actually, because the overall frame looks similar, and that's it turns out to be very important for your end users, that they at least have this feeling that it's still the same application somehow, and the cornerstones are at least solid and look the same on all your application parts, right? And if we take a look at this now, we have independent deployments. We can say, okay, we can deploy this stuff independently of each other. Autonomous operations, again, I mean, I know I did this green and red, but in software development, it's never black and white. But usually you have autonomous operation on a micro frontend level, but of course, if your app shell breaks, you also lose your autonomous operations here because your whole application breaks, right? Your technology agnostic, it also depends a little bit on the implementation, right? We started a lot with that the app shell provides, for example, the framework, the app shell provides React, the app shell provides Angular, whatever you use. But we shifted now a little bit that we say, okay, the app shell is really just pure JavaScript, right? It's totally pure. We deliver the framework for the single page application in the micro frontend itself, and we try to isolate it now with web components. We will talk about this later. So you have again ways to make it technology agnostic, but if you drive your single page application framework from the app shell, actually it's not technology agnostic, right? And it supports parallel development, of course. We will take a look at consistent UI and consistent UX later. It supports smooth user interaction. Actually, that's a very good point, right? Because if you think of this hyperlink integration and transclusion, you really don't have this, right? Because you need to do these round trips all the time. But actually, app shell integration supports this out of the box. You have fast loading because you just load the microphone that you currently lead, and this is actually a good thing, because the idea again is when you put the app shell, when you put the single page application in the app shell, right? It supports the fast loading much better if you say, okay, each micro frontend brings its own single page application, because then you need to load the single page application framework again for each part of your app shell, right? So that's a little bit the trade-off here, right? If you want to go with the single page application framework into the app shell, or if you want to deliver it by the micro frontends itself. Yeah, and there's the last approach I want to share with you, and this is the so-called meta framework. Who knows about meta frameworks? Nobody. Okay, that's cool. Meta frameworks are crazy, actually. So what is meta framework? A meta framework is a framework on top of the framework, right? So it's already sounds crazy, but people do this. And the idea is that you have a meta framework, actually. So a framework on top of the frameworks. And this meta framework checks the routing. And based on the routing, it does the aggregation of your other frameworks, right? So it aggregates your micro frontends together, right? So let's say you go to catalog, right? And based on catalog, you have defined in your meta framework that you want to load this micro frontend here, this micro frontend here, and this micro frontend here. Yeah? And if you go to checkout, you will change this actually, right? So it's a route-based modularization actually, which is done on the runtime on the client, right? One approach to do this is actually single SPR. It actually does exactly this one. It did it with iframes before, and now it does it with web components. That's why they are technology agnostic, right? Because usually they did it with iframes, and everybody said, "Oh no, iframes, that's not a good idea, right?" And now we do it with web components. Actually, It's from the concept more or less the same, right? It brings us good isolation, but it's iframes in fancy, I always call web components, right? And if you take a look at this now, you have independent deployments. Of course, you have them because you can deploy. You made the framework independently. You can deploy your micro frontends independently. You have autonomous operations. You're technology agnostic, so you can really do this. You can really do this, and you can say this is a React application, this is an Angular application. I don't really see a reason for doing this, but actually that's one of the selling points of this meta frameworks, that they allow you in doing this, right? But of course, this has a big impact on the footprint of your application, right? It supports parallel development, of course, and it's consistent UI and UX. We will take a look at this in a second. It allows smooth user interaction, right? And it sucks a little bit when it comes to fast loading, right? But it looks really good. But you should never forget, right? It's a meta framework, right? It's a framework on top of the framework. So it sounds very complex, and it's very complex, right? And you really have to think twice if you really want to do this, right? Normally, it comes with a lot of overhead. And I've never seen a real-world example where we said, okay, I made the framework make sense for us. But maybe it's a good approach for you, right? So let's dig a little bit deeper into a consistent UI, right? This is my favorite topic, actually. Everybody wants to have consistent UIs, and it's not really easy to achieve. And then people try to find out what can they do to have consistent UIs, right? And then I come with very basic tips usually. I always say, yeah, at least you can have a CDN, right? Put your static files, put your logos on a CDN, right? So if you want to change your company logo because you have a 25 years anniversary and you want to change your logo for this purpose, that at least you can change the file there and you don't need to redeploy 25 frontends, right? So that's a very simple trick, and people say, yeah, okay, CDN, oh, cool. And then I say, what else do you have, right? And then I say a CMS, right? Use a CMS at least for your static contents, that you have unique, that you have common texting, right? It's very important. It turns out to be very important for customers that you have some kind of similar texting on your services, not only similar UI and UX. So I see a couple of companies who have texters right now. So these are people actually from UX research which try to redefine the texters and harmonize them over the services. So a CMS can help you in this, right? But of course, I know this is also not what people want to hear. People these days want to hear they should build a component library, right? Everybody's using component libraries these days. Everybody really starts to build their own component libraries. That's the hot topic at the moment. It really has momentum to build component libraries. And I'm a little bit reserved when it comes to component libraries. Why do we do this actually, component libraries, right? The idea from, if you talk to people who decide, okay, we need to build our own component library to ensure that our UI is consistent, the idea they always have is something like this, right? So they build 3 single-page applications, right? Single-page application A in 2019, and then each year a new single-page application, right? And then they say, you know, the great idea, we extract a little bit of our components, we harvest them, and we say, okay, we have a component library based on single-page application A. So it takes a little bit more effort in the beginning, but at least we have something we can reuse for our second single-page application, right? And then we do this again with single-page application B. It still takes a little bit longer because, you know, you have to add components, you have to redesign other components, you have to make them more extensible and flexible, right? And maybe in single-page application C, it already pays off, right? You're already at the break-even point, right? And you say, okay, you have now a component library which you can reuse, and maybe for the next project, it's already cheaper to build it because you already have your component library, right? But there's one fundamental mistake in this calculation, right? And this fundamental mistake is, again, we're on the front-end platform, right? And what you actually do with such a component library, you make a promise, right? You make a promise to the future, and you say, we build a component library not for the next 3 months or not for the next 2 years, right? We build it for a long term. We build it for 5 years, right? We want to save costs with our component library for the next 5 years, right? But the thing is, you cannot do this promise in the front-end world, right? You cannot say, we build a component library now and we will be able to use it in 2022. This is just not working. Nobody can give you this promise, right? And so this is one of the fundamental issues we have here, right? And this is actually one of the reasons why we should really think twice if we want to do this, right? It's really not the way that component libraries will save you a lot of costs. That's just a wrong assumption in my opinion, right? And the second issue we have with those component libraries is that we, of course, create dependencies, right? We introduce dependencies between our single-page application frameworks, right? Single-page applications. And this is actually one of the reasons why so many people still stick with AngularJS, right? Because they build a lot of stuff with AngularJS. They build a lot of huge component libraries with AngularJS, right? And they invested a lot in this, right? And so what can they do now, right? They can upgrade their component library written in AngularJS to something which is called Angular, right? But then they also have to update all the applications in a big bang, right? And this is normally not working, right? So what can they do else? They can say, okay, we build a new component library in Angular, right? But usually that's very cost inefficient, right? Because you need to update the AngularJS library and you need to update the Angular library, right? So usually people don't do this. And what's left to do, right? They say, okay, we have all this stuff now in AngularJS. We just write our new applications also in AngularJS, right? And this is usually when developers start to quit, right? But that's really a big issue, right? And we have this because we have this dependency between our single-page applications, and we have this promise, and we cannot give this promise actually that we can reuse stuff for a long term in the front-end world, right? So sometimes here, copy and own approach is much better, and I know I see the fear now in the eyes of developers, right? If I say copy and own, right? The application is always bad, and it was always considered to be bad, right? But sometimes in the front-end world, I'm here with Rob Pike, the inventor of Go, who says a little copying is better than a little dependency sometimes, right? And I think especially for these reasons, it's true, because it's always a trade-off, right? Do we want to have duplication or do we want to have dependencies, right? And the trade-off is hard to find, but especially when it comes to ecosystems where you know that the technology changes a lot, right? Maybe a dependency is even worse than in other ecosystems, right? So that's the first one, right? Dependencies really kill you in this area. And the second one is that the design system must not be a component library, right? So people start to do this design systems things now, right? So human-centric design, and I really like this a lot, that people try to put the humans back in the center of the development, right? Because somehow we lost the contact to the people we write the software for, right? So we say we have these design systems, right? And as developers, if you hear design system, we actually think immediately of creating a component library, right? Which implements this design system, right? But on the one hand, this is not true, because you have multiple layers or multiple abstractions how you can implement design systems, right? The simple one is, you know, low fidelity mockups, right? Actually, Mockito or something like this, right? Then you have this high fidelity mockups with Photoshop, sorry. Then you have design toolkits like Sketch and stuff like this, right? Then you have design specifications, which you can, for example, create with Zeppelin. And last but not least, you have the technical representation as component libraries, right? So you have this range of options you can use to implement your design system, right? And it turns out, at least it's our experience, that the design specifications, right, Zeppelin files. What is a Zeppelin file? A Zeppelin file is more or less a technical specification of your design, right? It gives you, for example, the CSS properties and all this stuff. Is quite a good source of truth, right? Because it doesn't give you some kind of technology. It doesn't give you a dependency to a specific framework. It just shows you how you can implement this stuff with React, Angular, Vue.js, or whatever you like, right? And this is quite powerful, because I mean, how much work is it to create a button in React, right? It's not that it takes you days, right? And if you have already a very technical design specification, it's even faster, right? So it turned out that this is really a good way, right? You don't need to deliver these component libraries all the time to have a design system. Sometimes a design specification is good enough, right? And I think that the sentence I like here a lot, and I often say to my clients, is even if something has to look equally, it doesn't mean that it has to be technically the same, right? And this is somehow related to this application stuff again. But I think that's really important. Even if you have two buttons on single-page application A and single-page application B, it doesn't mean that it has to be technically the same button, right? This is not true, right? And we should change our thinking in this way, that we don't believe this anymore, right? But if you want to create a component library, right? If you say, we need this, right? Because we built tons of single-page applications, right? We have each month a new single-page application. For us, it pays off to create such a component library. At least there are a few things you should really focus on, yeah? If you need a component library, we then build it framework agnostic, right? So this is the best advice you can get for building component libraries. There are multiple ways to do this. For us, JSX plus CSS modules worked great if you don't have to, or if you can ignore Angular, right? But for nearly any other front-end framework can render JSX and can render CSS modules. And if you need to do Angular, maybe web components are a good fit for you, and there are a couple of frameworks who help you in doing this. I will not go into details about this because we have too less time. But actually, if you really build a component library, and that's really important, don't glue yourself to a specific framework and a specific framework version, right? So if we go back now to the Meta framework, and if we thought about this consistent UI and UX, we see that it actually is actually a quite good fit, right? But we said it has a lot of overhead, right? We have a Meta framework, right? We have a framework on top of the framework, and actually we don't want to have this, right? But to be very honest, it's not the fault of Meta frameworks, right, that we're in this situation, because as I see the future of web development, it looks somehow like this, right? We started with JavaScript, we decoupled us from the DOM, we started to use Angular React, and I think we moved back again to JavaScript, right? Because if you think about the USPs of those front-end frameworks like React, it's about creating components, right? That's what they do for us. They allow us to do this component-driven development, right? They allow us to create components. But with web components, we will get this into the platform, right? We will have this baked into JavaScript, right? So actually the purpose of frameworks will not be that they give us a way to create components. The purpose of the frameworks will be that they give us allowed to do routing and state management and all this stuff, right? So I always say I think the Meta frameworks will be the frameworks of the future, right? And if you think about this, then actually it's quite interesting, and it will show us that Meta frameworks are not wrong by definition, right? Even people blame a lot about them, and they even make jokes about them because they say it's just stupid building a framework on top of the frameworks, but it's actually not the Meta frameworks' fault, right? And I think Meta frameworks will be the frameworks of the future, right? So if we recap all this, and if we summarize all these approaches we've seen so far now for micro-frontends, we have two axes actually, right? We have the modularization axis where we say, okay, we have Hyperlink integration, right? We have app shell integration, and we have Meta framework. So on the left-hand side, we see one micro-frontend per page, right? At the app shell integration, we have a little bit better ways to modularize our stuff, right? And on the Meta framework level, we have huge possibilities to modularize our Meta frameworks, right? Our micro-frontend, sorry. So that's the first axis, right? And if you then go further and you take a look, you will see that there's actually a second axis in all this, in all the approaches I showed you, and this is the integration time axis, right? So you have different ways where you integrate your stuff, right? In these three examples, we have it on the front end, right? We have a front end integration. Here we have the back end integration, and we saw Transclusion for doing this, right? And then we have a build time integration, and we saw the build time integration. I call it build time integration approach, right? Where you actually build more or less a monolith again, right? And this is actually, when you think about this is the frame you can work in, right? And this is the solution space you have for this micro-frontend topic, right? So what kind of approach should you use, right? This is actually, if I show people this, and I do this actually a lot at clients, I say, hey, this is what you can do. And they say, okay, what should we use? And then I always say it depends, right? Because I'm a consultant, right? And I always say it depends. But it's so true, right? You cannot make this general advice and say, yeah, let's go for app shell integration. It's always the right one, right? It's just not true. You really need to know your problem. You need to know your domain. You need to know a lot about the project you're working on. So people still don't really like this answer, right? They really say, okay, you say it depends, that's fine, but what should we really do, right? And they usually don't have the time that I work with them for a couple of weeks or even months to really find out what's the best solution for them, right? So I did something, I'm not really proud of it, but it turns out to be quite powerful when it comes to talking with customers. I did a good old decision tree, right? And I did it from the left-hand side to the right-hand side, so you should read it like this. And actually, I started with the first question I ask those people there, and usually, is your application big, right? And this is really that's the trickiest one actually, right? Because what is big, right? And I don't care if you can feed your micro front-end team with one pizza. That's totally unnecessary for me. I define it in this way that I say if your application is big enough for micro front-ends, if you have the two most unrelated pages, right, of your application, if they can have differences in the UI consistency, right? If you say the landing page can look slightly different than the user profile settings, right? If this is possible, right, then go with micro frontends. If this is not possible, then just go with the build-time integration approach, right? Because otherwise you will really break your fingers, right? It will really hurt, right? It's so hard to make distributed frontends, and they should look equally all the time and everywhere, right? And if this is the case, if you say, no, that's the most important thing for us, right? It should be consistent end to end, right? Then go with build-time integration. It's much healthier, it's much more efficient, and it actually turns out to be not really possible if you have distributed frontends, right? But if you say, no, it's not an issue, the landing page can look a little bit different, for example, like the user profile settings, which is usually the case, right? And then you need to ask yourself, do you have strong and independent UI or domain parts, right? And if you have them, right, if you have strongly independent parts of your application, like we saw the landing page, the products page, and the checkout page, then maybe go with hyperlink integration, right? This is, for example, what Amazon does, right? If you go from Amazon, from the product overview to the checkout page, you will see that these are total different applications, right? Sometimes they even don't share the same logo, right? They're total different. You normally don't realize this because it turns out that also for us as human beings, if we see, okay, it's a total different domain, right? It's a total different bounded context. It's okay that the applications look a little bit different, right? But if you don't have this, you need to ask yourself, do you need smooth user interaction, right? And if you need smooth user interaction, or if you don't need it, you can go with Transclusion, right? With server-side includes. But if you need it, if you need smooth user interaction, you need to ask yourself, do you need complex modularization, right? And I never, as mentioned earlier, I don't want to blame meta frameworks here again, but I never seen a customer project where we really needed this, where we really said, okay, we need to use a meta framework, right? Because we need to modularize all our micro frontends on a very low level, right? So we usually end up with building our own app shells, right? And the app shells should be very simple, and it turns out that they should be framework agnostic. So the app shell should not include the framework, but the app shell should be pure JavaScript or things like this, right? And this is usually what guides you quite good through this decision. But it's still not really true, because if you think about it, what you should really do if you have such an issue, if you want to slice your front end into smaller chunks, what you really should do is you should compose a perfect mix, right? And what I mean by this is, I always bring this Amazon example because it's the domain is quite simple and everybody uses Amazon and understands it, right? So if you have an application where you say you have a landing page, right? You have a shop page and you have an ordering page, right? Maybe a good way to slice this application in the first instance is just really hyperlink integration, right? Because you can say, okay, we are very decoupled, and maybe we want to be this even, right? Maybe we want to have a very decoupled landing page, right? Where we say, okay, the landing page, 80% of the traffic goes to the landing page, right? So it needs to be very fancy all the time. We need to redeploy it very often, right? We need to use the latest UI stuff here, right? Because it's so important that it looks good, right? Then we have the shop page maybe, right? It still can be fancy, I guess, but it doesn't need to be that fancy as the landing page anymore. And it has total different release cycles than the landing page, right? And then we have the ordering page, and we just link them together by hyperlinks, right? So that's a very easy approach, and that's what I mentioned earlier. This is what Amazon actually does, right? But if you go then into the shop, you see, okay, it's still a little bit big, right? We need to slice it further, right? And then you maybe say, okay, for the shop, an app shell integration is a good fit, right? So we say, okay, we implement the shop with an app shell integration approach. So we can still parallelize the work on the shop, right? And maybe for the ordering, right, we use Transclusion because we don't have this problem with an additional server round trip, right? It's okay for us that the user clicks on, let's go to the next page to enter the address, right? It's not an issue that he doesn't have this smooth user interaction anymore, right? And so you really need to design your front end in a way that you really think, what does the user currently expect here, right? what are the downsides and what are the advantages, right? There is no one-size-fits-it-all solution for this, right? You really need to be creative, right? And you need to think, how can we slice the front end here, and where's the best way to integrate it? Is it maybe on the front end? Is it maybe on the back end? Is it maybe better to just integrate it with hyperlinks, right? So actually, that's the key takeaway, right? And if we take a look at this now, and I did a couple of talks about microservices earlier, and I always said, you know, the most important thing about microservices is not to start with them, right? And the same thing turns out to be true for microfrontends, right? If I see people now starting to do microfrontends because it has some kind of momentum right now, right? People read about it and people hear it and people say, yeah, cool microfrontends, we should do this, right? Don't use it from the beginning, right? You will make lots of mistakes and you will cut your application in total useless chunks, right? And it will just be a pain. It will really slow you down in development, right? Start with a monolithical approach. Start with a monorepo, right? Where you say, okay, you have some kind of good modularization. You really get problems. You take out stuff, right? And you build own microfrontends out of this, right? So actually the same idea like with microservices, where you also say you want to have a monolithic first approach, right? The same is true for microfrontends, so this is really important one. The second key takeaway for me is always the 8 facilities of distributed computing. I don't know if you know them. If you don't know them, you should look them up. They are called facilities for a reason, right? So if you really go into this role of microfrontends, you need to know that actually what you're doing is you're doing distributed systems on your front end, right? And distributed systems come with some kind of complexity and some kind of facilities you should be aware of, right? And I think this is very important to notice, right? Because a front-end monolith has its advantages, right? It brings a lot of simplicity when it comes to runtime things and when it comes to error handling and all this stuff, right? So please be aware that if you do microfrontends, you do distributed computing on the front-end side. And last but not least, and that's really important for me personally because I always thought like this, right? Really consider the front end as a critical part of your microservice architecture, right? It's useless to build the best scalable microservice architectures if you don't have front ends which support you in doing this, right? If the front end is your bottleneck, you don't have any chance, right, to deliver a good service to your customers, right? So that the UI is really a critical part of your microservice architecture, and you should solve UI-specific problems with UI-specific solutions, right? If you would solve it like you do it in the backend, you will end up maybe with Hyperlink integration everywhere, but we saw that this is not always the best solution, right? So at the end, this was quite fast, but I had to bring a lot in this 60 minutes. So in the end, it turns out to be as simple as usually, right? Use the right tools for the right job. I'm David Leitner. I'm a non-hype train activist, and I'm writing code. I hope this was useful. Thank you very much. This was very stressful, I have to say. I need more time next time. I pushed a lot of stuff into it before I started it, and usually that's not a good idea. But it turned out to work. Any questions? Yeah. Sorry? Yeah, exactly. Yeah. It's always the same. Yeah. Yeah, maybe, yeah. No, it's a little bit different when it comes to details. Yeah, definitely. Yeah. I mean, this component-driven development is not new, right? We did this in GSF already, or in old frameworks, right? Wicked was really good in this already, right? But it was still rendered on the back end. The main difference is that we do it now on the front end. Yeah. For sure, for sure. I mean, that's the whole idea of microservice, right? To build stuff in a way that you can replace it easily. Yeah. No, no, it was not really specific about micro frontends, this topic. It was more about, component libraries, right? Because, you need some, if you build distributed frontends, you need some tooling, which are some tools which allow you in having consistent UIs, right? Because you have distributed UIs, so you need to somehow ensure that UIs look similar. And one way to do this is component libraries, right? And this slide showed the disadvantages of component libraries, right? And maybe why copy and own approach is a better way to go here to cut the dependency. Exactly, yeah, I mean, this was the copy and own stuff, right? Maybe sometimes really duplication is a little bit better than a dependency, right? That's always this trade-off. You had a question, right? Okay. Okay, thank you very much.